in the clay itself.
With has a piezo and therefore implosive capacitance and therefore
Yes.
bioactive and fun
Yeah.
stuff. I'm just launching the YouTube live here. We can go ahead and see if this is working. Here we go. Three, two.
In the clay itself. Yeah, it's
But
yeah, in the
as a
clay itself.
piezo and therefore implosive capacitance. There we go. Okay. So we are now live on YouTube, everybody. We're coming along. Dan Mac, why don't you just show that cup one more time so people see it?
Yeah, this is for Guillermo. He might show up today. He's on the East Coast right now visiting family. In fact, yeah.
So
And
there's the Grail cup within the cup. Dan Mac is
yep,
holding the Holy
nice.
Grail right there. And and uh and Aircrete Harry is building his own version. Why don't you hold that up? Look at
Yeah, I can see the difference just by looking at this shape is pretty good, but I think if it was more perfected, like printed like that, you'd have the actual, you know,
actual implosion. And they make a
yeah,
bioelectric field and they change the flavor of coffee and wine. And this is
yes, it
the Grail.
does.
So hi
And
everybody.
we may have some of those during our conference in September, and we could do some testing.
Ah, yes.
I'm bringing a bunch of them with me when I come to the
Great.
conference.
Cool, cool. So you came in amidst the fun, everybody. Hi, I'm Dan Winter, FractalU.com, FractalField.com. That was Dan Mack sharing the Grail Cup and Aircrete Harry sharing the Grail Cup. And we have our host, Tufan Guven, who will have announcements in a moment. And our special guest star, guest speaker tonight, a world expert on John Dee and all of the symbolism of implosion and John Dee's work on scintillation, many things. Monas Hieroglyphica. We have a show, a story to tell. Jim is amazing. So, but before we do that, let's see. Do we have announcements too, Fan? Any suggestions?
Yeah, we do have a few announcements. Starting with next week's lecture, we will be hosting Mauricio Lopez from Assumption, Paraguay Terafy Center and the Plasma Healers Support Group. And our subject will be plasma healing, group work, and distance healing with yoga, breath, and biofeedback. And also regarding the South France conference in September this year, so as many of you already know, due to high demand, all rooms are booked except for a few reserved rooms that will be finalized by June 15. We anticipate that some reservations will be canceled, leading to openings by mid-June. So if you still want to join the conference, you can either arrange your own accommodation outside the event venue and still contact us to join the conference, or wait for openings. We expect some openings by mid-June due to canceled reservations, and we will start contacting those on the waiting list at that time. So if you wish to join the conference and prefer accommodation at the event venue, please send us an email at info@geometricmodels.org, and we will do our best to assist you. And also, next week lecture will be our last lecture in this FractalU program, and we would like to thank you all for supporting us throughout this program. And we will be doing the lecture same as usual, 2 p.m. New York time. You can take it over then.
Thank you, Tufan. That was excellent. Yeah, I was just talking with Bridget Nielsen. She's coming with her mother. You know, she's amazing. And about plans for the South France Grail Mysteries event. You know, that's September 19, everybody. The website is fractalfield.com/2024. And boy, is that going to be fun. Our friends are getting together. So, yes, go ahead, Dan.
I just have one question. The breakfast on Tuesday morning, it's, you got to get to the train station and then the train station, but the flight from Barcelona back to United States leaves like early, it's like 11 o'clock, 11 a.m. local time. So I'm wondering if I should book another night and then figure out another way, because you said there was transportation from the venue
Yeah,
to
so
the
that
train.
we can get you to the train. The train is only about 7 minutes from the venue, but that
Oh,
train to Perpignan is 35 minutes, and then you have a bit of a wait, and then you have the 2.5, 3 hour train to
yeah.
Barcelona. So we have to study that. But you're right, you might need another day because to have it be comfortable, you either got to get there the night before, or yeah, we'll help you with the details on that.
Just
And
to
we have
get
people
used to
that
it.
Yeah. Okay. To be continued. But
Thank you.
yep, you're welcome. And we're at your service, Dan. Okay. So the subject for this evening, Jim Egan. Jim is a real involved expert on the mathematics behind the symbolism of John Dee's Monas Hieroglyphica, and also how it relates to purportedly John Dee having been involved in the design of the Newport Tower, the famous geometric landmark there in New England, USA. And Jim runs the Newport Tower Museum. And I love it because, as we were just discussing, in terms of the physics of John Dee here, I think, for one thing, probably, maybe Jim would comment later, that the Newport Tower itself is probably on a magnetic line of some sort, meaning longitudinal node, meaning, a place for telepathy and the longitudinal array, so to speak. But in addition, seeming to have designed the pinhole mirror physics principle into the way the Newport Tower was built. Remember the pinhole mirror, that slide we have, where the light turns inside out in the pinhole camera, being analogous to what John Dee called the scintillation point, where literally where the scintillation, where the twinkle is, being what John Dee was experimenting with, for example, using scintillation points as part of his work in scrying and ancestor and angel communication. So I think it's my view that John Dee was very close to understanding that phase conjugate optical and phase conjugate electrical compression points are the physics of DNA radio, the longitudinal array, how you make ancestor phone calls and angel phone calls, is all about these twinkling points, even also in the way that John Dee used the showstone, which we think was either an Aztec or Olmec ancient ancestor phone call mirror, the showstone of John Dee, again, for scrying, for communicating with elementals and angelic forces. In other words, all of these things that we have been calling the hidden realms and ancestors and ghosts and angels, all, in my view, have systematically to do specifically with the compression nodes in a coherent longitudinal EMF array. That's why when kids learn to do that implosive compression in their brain waves, as we talked in our last session, that not only do they start seeing without their eyes and probably lucid dreaming, but they also often become clairvoyant and start seeing ancestors, which is exactly what John Dee was trying to do. And the physics behind that, which is literally the mathematics of discovering how path curves converge, then implode, then conjugate, and make this magic communication point of the scintillation point of the longitudinal array, where Korotkov and Kozyrev proved where the magnetic lines cross on Earth was the place of high quality telepathy, for example, and where Kathy proved that nuclear critical mass is reduced. So it's all about understanding the science of the nodes in a longitudinal array, and these are ideas that really twinkle. Now, also, I understand that Jim Egan is using metaphors from Bucky Fuller. I may be one of the few old farts, the old scientists who can say that I learned how the vector flexure does charge collapse personally from Bucky, my friend in Detroit and in Florence, Italy. And so the geodesic ideas, and as they presage these ideas we are now working on of charge collapse, from Bucky, is a beautiful way also to talk about what John Dee was working on. Anyway, so there's lots of reasons why I find it cool and fun that Jim Egan is here to talk with us tonight with his incredible enthusiasm. So without further ado, Jim, the floor is yours here.
Okay, let me put on share screen here, and
that's a beautiful lab you have there, Jim. We like the color of your environment.
it's an artist's mind as it works.
Nice. Sort of... we got your screen, Jim. You're good. You're good. Looking good.
Excellent. So you can see the slide, John Dee's mathematical cosmology, as explained cryptically in his Monas Hieroglyphica.
Yes.
Correct? You got all of that stuff.
Yep.
Okay,
Absolutely.
good. So
absolutely.
So I'm not going to talk an awful lot about John Dee because about his whole story, because there are several books, The Arch Conjurer of England, The Queen's Conjurer, they can give you the whole story on it, but I'm most specifically going to be talking about his Monas Hieroglyphica, which is a book he wrote in 1564. Let me just get this right here. Boom, boom. There we go. John Dee lived from 1527 to 1609. And he was born in London, and then he went to St. John's College in Cambridge. And then after that, and then he went to Trinity College. He taught Greek, and then he went to the Louvain and studied under Metamorphosis, a very brilliant fellow, and he got to know a lot of people in Antwerp. Now, the Renaissance started in Italy, and it moved up into the Northern Renaissance, but it had a slow time getting across the Channel. John Dee brought this knowledge back, and that's why he was 50, 100 years ahead of his time. He was also a very learned man, and he had a library of over 4,000 books. And his library catalog has been compiled. You can buy a copy of it for $150.
Wow.
It explains all the books. It's written in Latin, and he wrote down in 1583 every book that he owns. And on the left side, it says FR or T. T refers to he took it with him on his trip to Europe. And FR means he didn't take it with him. He left it with Frohman, who is his wife's brother. And so you can tell his favorite books, or at least the ones that he put in trunks. And he put a lot of the books in trunks and carried with him all the way across Northern Europe to Prague and then back again. So, but these books go not only from the Greeks, the Arabs, all the great Renaissance study. He was just such a learned man, and he spoke fluent Latin, Greek, and he knew some Hebrew, and he knew Italian and French. I mean, he was just a polymath. He put all the minds that are watching this show together today. That's what Dee was. And in the Renaissance, it was just amazing. Anyway, he was also the navigational guide to all the great Elizabethan explorers, Martin Frobisher, the Northwest Passage, Stephen Burrow, the Northeast Passage. And he was a cartographer. This is John Dee's circumpolar projection from 1582. You see the North Pole is up on the top there, down a little bit. That's the prime meridian used to go through the Azores, and then to the right there you'll see London and England, and then off to the left is the New World. And there's actually a little island there that's labeled Claudia, which is a little island off of Block Island that Dee knew about. So he was not just a cartographer. I mean, his best friend was Gerard Mercator, the famous one. And so in 1588, Dee writes this book called Proputumata Aphoristica, which is Greek for preparatory aphorisms, 120 aphorisms on astronomy, on stars, the distance from the stars. And they're all very short aphorisms. And this is the front cover. And you can see in the center there, dedicated to Gerard Mercator. And underneath that is this Monas symbol. This is a symbol that John Dee devised that has the moon on the top, then the sun, that circle on it. And then beneath that is the cross of the elements, he calls that, fire, air, earth, and water. And then he has at the bottom the air symbol for Aries, which is the first of the zodiacal signs. So in this one sign, he's got the sun, the moon, the stuff on earth, and the planets. The whole universe is in this one little symbol, but there's much more to it as well. Dee was very clever. On the left, you'll see these columns. These are of the Corinthian order, actually pilasters. They're flat pilasters, and one's the sun column and the moon column. Anyway, in this book, he has only one chart. And this is a chart of, he calculated the number of conjunctions between the 7 planets, how many different variables you could, whether they were even and uneven, all these different ways. But I want to point out in the center is this one equation, 120 times 21 equals 2520. And we'll come across that again in a second. I'll explain it to you. But there were also 120 aphorisms in his book. That's exactly the number that he chose. But this led up to another book that he wrote 7 years later called the Monas Hieroglyphica, Sacred Symbol of Oneness is how that translates. And he dedicates it to the Holy Roman Emperor of Maximilian, who was a Holy Roman Emperor of like all of Northern Europe, Bohemia, Hungary. And so Dee's book, you can see the front cover, is very similar to the previous one that he did, where he's got the sun column, the moon column. And then up on the top, above the columns, it says Ignis. That's fire, air, earth, and water. He has the four elements. And in this egg shape in the center is the Monas symbol. Off to the left is the symbol for Aries, and off to the right, Taurus. And then down at the bottom is a symbol for Leo the lion. That was Maximilian's birthday. And up at the top is Cancer the crab, that lobstery thing. That was Dee's birthday. So there's all this hidden stuff. And then this wording that says on the side there, Mercury, when made stable by a single point, becomes the parent and king of all the planets. Anyways, up at the top, I'm not going to explain it all today, but up at the top it says, he who does not understand should tasiat o decad, should either learn or keep silent. Well, the queen finds out that he has printed this book, and she calls him in and says, John, I want you to explain this book to me. I promise to learn and keep silent. She played a little riddle with him. She was very clever. So he explains it to her. When he goes to Prague, he explains it to the emperor. Excuse me, one way here. Now, this book, the Monas Hieroglyphica, has been translated 4 or 5 times over the years. One of the best known ones is the 1947 translation by Hamilton Jones. And Hamilton Jones, he was an okay scholar. He kind of understood this stuff, but he also translated this on his ride back. He bought the book in London in Latin, and he translated on his trip back to the United States after World War II. So he was on a boat and such, and fairly good translation. There's also a very early translation, which is up into the Glasgow Library by Anonymous, 1691. Now, this was useful for me because it had a lot of the expressions that people used back then that we don't use anymore, and it made sense of a lot of these expressions. But the main best translation is done by C.H. Jostin in 1964, published in the Journal of the Society for the History of Alchemy and Chemistry, called Iambics. And so when I was writing this book about John Dee, I said, well, I can't really explain what the Monas Hieroglyphica about unless I had the translation that they gave me. So I called them up on the phone in London, and I said, look, I'd really like to reprint this from in my book. And they said, you know, we make money off of our that publication, and we sell it and such. And they said, we don't want you to use it. And the editor says to me, why don't you just translate it in your own light? And I'm like, I don't know Latin. So anyways, I hired a Latin translator. I got all the known translations and set them out on a table. And what I found out was that, you know, in any Latin sentence, there's 25 different ways you can translate it. Each word has 5 different shades of meaning. You put that all together. So I put them all together. And when I did make my own translation, I'm like, oh, I get what he's talking about, this guy. And so some people have taken it the wrong way. They get very alchemized about it. But he's really just talking about numbers and mathematics. This is my translation on the right there, Sacred Symbol of Oneness. And you can buy these for $10 each on Amazon. But, and so people today, even if you haven't read the book, don't worry, you don't have to have read the book for learn what I'm going to explain today. You can read it afterwards. But I'm just going to go through and explain briefly, mostly today, what it has to do with numbers and geometry. So this is the first page. He dedicates it to Maximilian, the head of Northern Europe. And he also writes this note, Dee does, to Guillermo Silvio, who was his printer. And Dee took this book. He could have got it printed in London, but he wanted it done by the finest Renaissance guys. He's like, I don't want any mistakes in this book. Dee was very much, everything had to be, he says, I want every point, line, and letter has to be correct. Please do this so that my child, he calls this his child, will make its way into the world. And so he writes this to Silvio. Then the first page here you see the first 3 theorems. Theorem 1, theorem 2 is all about point, line, circle. Dee says the first things in nature, the first things was the point, the line, and the circle. And he says, the point was first, and then the line, because it connects 2 things, and then you can't have a circle unless you have the point and line, so then the circle comes. And what he's talking about is a radius. You will take that and you can arc a circle if you have a radius and a central point. And then down below in theorem 3, he discusses the monas hieroglyphica, and in the next theorem he breaks it into the 4 parts: the moon, luna, the soul, the sun, the elementa, the 4 elements in the fire of Aries, he calls it. And later on in the book, he gives the geometrical construction for the monas symbol, which, the half circle is the moon, and then a full circle, and then the diameter of the circle and the moon is the same as the lines of the cross. It's just an offset cross, not equilateral. And then the Aries symbol, or each half moons, he says you have to make it exactly these proportions, otherwise it loses all of its virtue, all of its power. So I'm not actually going to talk too much about the monas symbol today, but what I really want to talk about is D's numbers. At the very end of his book, he has these 2 charts, and this one's called, it's part of his artificial quaternary chart, and then there's another one, which I'll show you in a second. But this chart here has 3 parts to it: virtue, pondera, and tempora. So here's the translation: virtue, weight, and time are the 3 things. And off to the right, these various things, the grades and all of this. Well, I'll explain a little more what those are all about in a little. But I wanted to read what it says on the left side here. And I want to read it very dramatically, because this is very heartfelt for D. This is not fun and games. Our numbers have such dignity that to violate their laws would be a sin against the wisdom of nature. Indeed, these laws announce with authority the certain and fixed limits that nature wants to teach us in the examination of its greatest mysteries. I just love that. I mean, it's just, he's like serious here. And then he says they are, and he explains the whole thing. So at the very bottom of this, you'll notice that it gets into this, these are alchemical stages down at the bottom. And then very bottom, it says the magisterial number, the greatest number. Lapidification, fermentation means the philosopher's stone of number is 252. 252. And I'm like, whoa. He says, basically, he's saying, if you can figure out what I mean by 252, you'll figure out this whole book. So I'm like, oh, I got to try and figure this thing out. Now, 2 squared is 4, and then you get 8, 16, 32, 64, 128, 256. That's 256. That ain't 252. What is 252 all about? Well, it's a palindromic number, the same forwards as backwards. It sums to 7, the digits of and stuff. But those are only clues. What does it mean, and why is this one Renaissance really smart guy revolve his entire book, his most cherished book, on this one number? The second chart D has, it's a summary chart called Thus the World Was Created, on the right, Sic Factus Est Mundus. And there's 2 parts to it. There's the super celestial half on the top, and then at the bottom is this etheric celestial part on the bottom. And this is my translation of it. On the upper left-hand corner, you see the horizon of eternity, metamorphosis, consummation. And then off on the right, this quaternary, the number of our monas, the sabbatisat, the ultimate power of nature and art. And down at the bottom are these listings on the far left: 1, 2, 3, 4, first 4 numbers. And then you've got earth, fire, air, earth, and water, 1 through 1,000, the monas symbol. And then upside down at the top, and then backwards, and then this one's missing the sun circle, and then these numbers 1, 4, 7 kind of offset this realm, body, mind, spirit, 1, 2, 3, and then black, clear, yellow, red. These are alchemical stages, and then the alchemical stages are actually let me see here if we can do this. Tenebrae, crystallina, citrinitas, and anthrax. I've translated them to the colors. And then 12, 13, 24, 25. No one's been able to figure out the chart for the last 450 years. I'm like, well, you're talking to Jim Egan here. You could try to do anything. I said, D must be making some sense, meaning something. So Dee starts his book with the first three things in nature: point, line, and circle, which is kind of like the numbers 1, 2, and 3. And so I just make this association of 1 is like a circle, a wholeness, it's wholeness. 2 is like a tangency, two tangent circles, polarity, duality, and then 3 is asymmetry. There's always, when you have three things, if you got three things and three people that want to play tennis, there's always going to be 2 on one side and 1 on the other. It's like the oddball thing. So the thing they have to understand about 1 is 1 back in Dee's time and all the way up until the 1700s, nobody thought 1 was a number. They thought it was the source, the wellspring of all the numbers. They didn't consider a number, even Aristotle says, no, the first number is 2. We don't think that. We go like, well, I got a cell phone. Look, I got 1 on the cell phone. I live at 154 Mill Street. And I'm like, this, what do you mean it's not a number? I got 3 apples. You take away 2, I got 1 apple. What are you talking about? Well, that's our modern day thinking. We're thinking in terms of kindergarten numbers. We're thinking in terms of mercantile numbers, 1 and, but what they're talking about is the quality of numbers. And so 1 is wholeness. It's everything. It's universe. It's like, it's the whole thing. Then what happens is 1 gets divided into 2, and you have this whole other thing called duality, polarity, symmetry, and what's called a union of opposites. And then after that, you get asymmetry, and with 3 things. And then Dee and his compatriots at the time were very much into Christianity and the syncretic philosophy of melding the ancient world with modern world. And so the Holy Trinity to them was this idea of threeness, 3 persons in 1. Now, in terms of point, line, circle, now all of a sudden we've got a point is like a circle, like oneness, and then a line is like 2 things, because a line has two ends, and then an equilateral triangle is what is formed with these 3, the idea of threeness, the quality of threeness. Well, at the very end of Dee's book, he says, Amen, says the 4th letter. And then he shows an equilateral triangle. Well, he signed his name with an equilateral triangle. That was his name. The 4th letter in Greek is a delta, which is a triangle. And then that became the 4th letter in Latin, which is ABCD, which is his name. So he signed his name. In fact, a couple of times in his book here, you can see the triangles. It's just a quick way for him to say, oh, that's me. And he used it a lot, especially you'll see it in his angel conversations. You'll see Kelly and then the triangle D. So that's an important thing to remember. D saw the power of this idea of triangle. Now, the main thing about Dee's book is that he's concealing, cryptically describing, let me put it that way, 4 numerical sequences. Here they are: 6, 8, 9, 12, 1, 4, 7, 10. 1, 2, 3, 4, 5, 6, 7, 8, no 9, and 12 times the primes. Well, that's a lot to take in. I'm going to explain them all in a second. This one is called Nicomachus's greatest and most perfect harmony. This one is called the symmetry of the decad. And this is my name for it. Well, no, Dee uses this expression as well. In fact, he uses that in the book. And then Dee calls this consummata, which means to make perfect, consumption. And so, and then the 4th one is called metamorphosis. That's Dee's word for it, which is 12 times the prime. And I'll explain how these all work in a second. Let's start with Nicomachus's greatest and most perfect harmony. So we go back to 500 BC, and Pythagoras is walking around town, and he goes by the blacksmith shop, and he hears bing, 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 that they're hitting on the anvil, like in the picture here, and different sounds make different notes. And he goes back and he studies the resonance in water and in strings that are grown and in flutes, and he finds these ratios that he summarizes in this one very simple chart. It's called this tetractys. Tetractys means fourness. And so there's a row of 1, there's a row of 2, there's a row of 3, and there's a row of 4. It's pretty simple. Now, in Dee's book, he even shows us the Pythagorean quaternary, 1, 2, 3, 4. And then Dee says all of these numbers multiply to 25, they sum to 10, 1, 2, 3, 4. And there's 10 dots in the tetractys. And then if you take all the various combinations of it, it sums to 30. So he goes into this whole thing. But basically, the Pythagorean tetractys is a triangle, and that's D's name. So he knew this and loved all about this. Now, the important thing about the tetractys, the most important thing, is that the relationships between the rows make these harmonious proportions: 1 to 2, 2 to 3, and 3 to 4. And these are musicians will recognize these as the musical fourth, the musical fifth, and the octave. The musical fourth is do, re, mi, fa, do, fa, do, fa, do, fa. That relationship between those two, that's a fourth. And then do, re, mi, fa, sol, do, sol, do, sol. That's a fifth. And then the octave, do, re, mi, fa, sol, la, ti, do, 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 from one to the next. And I don't have the perfect pitch you do, Dan, but basically, musicians will understand these relationships are very beautiful in most harmonious relationships in music. So, Pythagoras was 500 BC and took a couple of centuries. And Nicomachus, around 125 AD, he was a Neoplatonist. He wrote a book called Introduction to Arithmetic. And it became the book for arithmetic for the next 400 years. And then in 525, Boethius, a Latin guy, he translated it, and then it became the number one book for the next 5 centuries. So for 10 centuries, this was the book. And at the end of his book, the last chapter, Nicomachus and then Boethius says, I'm going to show you the greatest and most perfect harmony. They are these numbers: 6, 8, 9, 12. Well, why? Well, among these, you get 6 to 8 is 3 to 4. 9 to 12 is 3 to 4. 6 to 9 is 2 to 3. And 8 to 12 is 2 to 3. And then 6 to 12 is 1 to 2. All the harmonious ratios are explained just these numbers, these 4 numbers. In 1509, Raphael, the great Italian painter, was asked by the Pope to do a painting for the wall in the Vatican. And he says, I'm going to show you, because this was the time of great synchronicity. They were trying to meld ancient wisdom with Christianity. So these are this called the School of Athens, this painting. And it has all the hot dogs from the Athenian brilliant times. You got Socrates is on the left, and then Plato and Aristotle in the middle. Down on the lower right, you got Ptolemy. He's holding a globe, and then Strabo or Zoroaster, they're holding a globe. These were the geographers, and then you got Euclid. He's got a team of geometers, and he's got a compass. He's showing them how to do it. Over on the left, you get Epicurus, the guy that loved eating so well. And then down at the bottom is Pythagoras, and he's writing in a book. Now let's go to a close-up of this. Surrounding him are famous mathematicians from later eras. So looking over his shoulders, I love the way he's looking, peering over his shoulder, is Nicomachus, copying down what Pythagoras is writing. At the top is Averroes, who was the great Arab mathematician around 1175. On the right, Hypatia of Alexandria. This was Theon of Alexandria's daughter, brilliant mathematician, a woman, 400 AD. Let's give it a hand for the women here. And then Boethius, he's the one that copied Nicomachus in 525. You can see he's kind of copying it. But in the center, right near the book where Pythagoras is writing, is sort of a little servant with long hair, and he's holding up a chalkboard. And let's zoom in on the chalkboard there. It says up at the top, Epogdun, and then there are these U-shaped things. And I've made my translation, diatessaron, diapente, diapason. What that means is the relationship. See it up at the top is 6, 8, 9, 12, and the bottom 1 to 2, 2 to 3, and 3 to 4. And up at the top, there's another relationship between 8 and 9. That is called tone. The difference between an octave and one more than an octave is the tone. That's 1/8 in music. So epogdun literally means 1 more than 8. Epogdun, and so down at the bottom you'll see that there are the Pythagorean tetractys, the 10 dots of 10. And he's saying that these harmonies, so this is Raphael putting it on, in front of the Pope in the middle of it. So this is very well-known Renaissance knowledge, these 4 numbers. And Dee melds this into his book. So here's one way you can see it up at the top of this one chart. He has 1, 2, 3, 4, which is basically the Pythagorean tetractys. And then in his thus the world was created chart, he has the Pythagorean, the quaternary, 1, 2, 3, 4 down the bottom, and he also has it on the top, which actually serves a couple of more purposes. But you can see these numbers, and so the next sequence is called the Symmetry of the Decad. I love this one here because Dee learned about this from a fellow by the name of Paracelsus. Well, Paracelsus's real name was Theophrastus Bombastus von Hohenheim. And he lived from 1493 to 1541. And in one of his books, which is called The Aurora of the Philosophers, he writes this, and it's really kind of heavy, but I'll read it slowly because it's very important. And you can see how important it is to this guy. Magic, it is true, had its origin in the divine ternary that arose from the Trinity of God, melding a little Christianity into it. For God marked all of his creatures with this ternary and engraved its hieroglyph on them with his own finger, just like Dee's signature. For the ternary, with the magical quaternary, produces the septenary, sevenness, endowed with many arcana and demonstrated by things which are known. When the quaternary rests in the ternary, then arises the light of the world on the horizon of eternity, and the assistance of God gives us the whole bond. When the quaternary and the ternary mount to the denary, then their regression or reduction to unity. And this is the heavy part. Herein is comprised all the occult wisdom of things which God has made plainly manifest in man, both by his word and by his creatures of his hands, so that we may have true knowledge of them. That's pretty heavy. So basically what he's saying here is the idea of you start with 1, and then you get to 4, and then you get to 7, and you get to 10. Now, John Dee had read this book, and he brought it along with him. It's in one of the books that he took with him when he went to see the king. Now, he went to visit Rudolph in Prague, and while he was there, he went there with Edward Kelly. If you're not familiar with the whole Kelly deal, Kelly was Dee's scryer. Dee hired him as a crystal ball reader, and they talked to the angels, and they had an audience with or Dee did with the king, and it went along pretty well. And then they introduced Kelly, and Kelly says to the king, he says, "Hey, we can make gold for you," and the king's like, "Okay." So Kelly's like trying to, they could. Anyway, Dee ends up leaving Kelly, and Kelly promises the king again he can make gold. Well, he doesn't make gold. He gets thrown into this cell, which you can actually still visit in Prague. And while he's in there, he's like, I got to find a way to suck up to the king. So he wrote down. He still had his books with him. He said, I'm going to write this book called The Theater of Terrestrial Astronomy. Edward Kelly, and what he did was he basically copied the wisdom of other books much earlier to present it to the king. Well, the king still wasn't buying it, and Kelly ended up tying bed sheets together, trying to escape out of the top window of this dungeon, and he fell and broke his legs and ended up dying. Well, that's the short story. But the point is, while he was up there, he borrowed, he had a copy of Paracelsus's book, because this is what Kelly writes in The Theater of Terrestrial Astronomy, and you can see the parallels. Magia is derived in origin from the doctrine of the divine ternary and the Trinity of God. For God stamped and sealed all the created things with his character of the Trinity, a kind of hieroglyphical writing. For the numbers 3 and the magic number 4 make up the perfect number 7, the seat to many mysteries. And seeing that the quaternary rests on the ternary, it is a number that stands on the horizon of eternity, that both exhibit everything bound in God, in us, which including God, men, all created things with all their mysterious powers. And you add to 3, you get to 10, which marks the return to unity. In this arcanum is concluded all knowledge of hidden things which God by his word has made known to men, and of his good pleasure, so that they might have true conception of him. Sounds pretty heavy. I mean, but basically he's just copying. Here's the boils down to 1, 4, 7, 10, and 10 is a return to 1. These are steps of 3 each. I call 3 the distribution number. Here's another way to look at it. And the idea of 10ness, we use our base 10 system. We get 1, 2, 3, 4, 5, 6, 7, 8, 10, and then you get 10, 20, 30, 30, 50. So 100 is also a return, and then 1,000 is a return. So there's this cyclical quality to it. The way that I like to simply summarize it is an equilateral triangle where 1 is up at the top, 2, 3, 4 is the lower right corner, 5, 6, 7 is the lower left-hand corner, and then 10, which is a return to 1, is back up on the top. So that is a very simple way to show it in an equilateral triangle. And of course, that's D's name, the equilateral triangle. So in his monad symbol, D shows these proportions in the height of the centers of these various pieces. Like at the bottom, the center of the Aries symbol is 1. The center of the cross of the elements, where he's raised this cross up, is 4. And then the center of the sun circle is 7. The center of the moon half circle is 10. And he even hides this beautiful number rhythm in his book. You'll see that theorem 1 is the first theorem on the first page. Theorem 4 is the theorem next. Theorem 6 is on the next page. 7. And then on the next page, there are a couple of lines of theorem 9, but basically the first theorem is theorem 10. So he ordered it so to hide his stuff. And in his "Thus the World is Created" chart, he even says the ancient enigma of the symmetry of the decad explained. Here it is. It's down in the lower left-hand corner. And then you'll see in here, he's got in one column, he's got 1, 4, 7, and then he's got all the multiples of 10. And up in the upper right-hand quadrant, he has this chart, and he has the word monas, the word quaternarius, and the word sabati, which is part of Sabatizad. I'll explain that in a second, but sabati means 7. And then the ultimate power of nature and art, which is 10, which is a return to 1. So in his other chart, he also he shows this symmetry of the decad. This is part of his artificial quaternary chart. On the left, you'll see he comes to the number 8 by adding his special numbers, and then you get 1, 7, 4, 3, and then over on the side, he's got the denaria up to infinity, 1, 0, 10. So these are all his clues about the symmetry of the decad in this particular one. So the next sequence, and I know this seems like a lot, but it's very important to understand these 4 sequences and how they're all tied together. He calls this consummata, which means to make perfect. And it's this 1, 2, 3, 4, 5, 6, 7, 8, null 9 rhythm. Well, this was taught to me by a guy named Robert Marshall. And when I was trying to figure out what 252 was all about, I Googled 252, and Buckminster Fuller showed up, and Robert Marshall showed up. And so Marshall and he lived in California. He was a hippie. He lived in Haight-Ashbury back in the summer of '67. He says, "Oh, I was friends with all the Grateful Dead. I knew all of those guys. Janis Joplin. I knew all of." He was in them, but he was like a Rain Man for numbers. He had this mind for numbers and symmetries of numbers, and that's what he loved doing. And so he taught me about this sequence called the cycloflex, and another one called the holotomes. Well, what I found was that these are the exact same things that John Dee calls consummata and metamorphosis. So I don't want to confuse you with Marshall's names, but I'll just call him by John Dee's name. So Marshall, he went to a guru one day, and he said to the guru afterwards, and he says, I have this mind for numbers. What number should I study? The guru says, study the number 108, sacred number of the Hindus. There's 108 beads on a mala, 108 bricks on the fireplace, 108 verses in the Rig Veda. And all of this 108 is part of the calendar system, this long-range calendar system in India. And so Marshall worked in a machine shop, and he invented this machine that could spit out numbers. This is before computers. Marshall never had computers. He would never email me. He didn't have email. He was just, we had to correspond by my mail. And he sent me copious notes. I have 4 boxes of all of the notes, because he said to me one time when I went to visit him, he says, you're my last hope, Jim. You're the only one that is interested in what I have to say. It's very important. So he taught me all this mathematical stuff. I'm forever grateful. So this chart that you see here, in the center of it, it goes from 1 up to 108 in the first cycle, and then the next one is up to 216, and then up to 324, and then up to, and he goes on. It's a 108 wheel, and so he studied the spirals in these wheels, and that's how he was able to understand what 108 was all about, and what 252 was all about. And what he basically found when I came to him with 252, he's like, oh, well, that's the opposite of 108. 108 is the sacred number of the Hindus. This is D's magical number. They sum to 360, a number of degrees in a circle. Perfect symmetry. So 360 degrees, as we see, is very important also in Metamorphosis. Oh, but Marshall even says to me, he says, you know, I found that at certain limits, there is complete symmetry of number. Well, basically, that's what Dee's talking about before that quote I read, the finite limits. But what Marshall is talking about is the idea of oppositeness. And, you know, in our mathematical language, we have plus, minus, multiplies, divide. But he's like, there's a whole other thing that mathematicians don't use much. It's called oppositeness. It's called retrosity, which means basically this two symbol is the opposite, which is this upside down U. These things are opposite to each other, but yet at the same time they're equal. Well, that sounds like a paradox. Well, welcome to the world. We've got a lot of paradoxes in this world. And he's saying what basically like hot is the opposite of cold, but they're both just temperature. Loud is the opposite of quiet. They're both just noise. Wet and dry. These are opposites, but they're both kind of the same. They're different parts of the same thermometer, basically. So this is my artistic interpretation. Black on white on one side, white on black on another side, just to give you an idea of what this is all about. But Marshall says, when you apply it to numbers, then you really learn something. So 29 is the opposite of 92. 341 is 143. And you just the opposite. Certain numbers have several transpalindromic mates. In other words, 270 and 72, but also 27,000 and 72. You just drop the zeros, and so these are called transpalindromes. Now, you know, mathematicians would say, "Oh, you just can't do that. You switch in the digits." But it has nothing to do with quantity. What's 29 got to do with 92? But when you see numbers this way, you will see symmetries that you would otherwise never see. So here's an example of the symmetry. Here's a chart that has the numbers from 1 up to 9, up all the way up to 99, all the single and double digit numbers. Now I'm going to take this chart and flip it over backwards. So you're reading from right to left instead of left to right, which is not unusual. The Hebrews does it. Chinese people do it. And then what we're going to do is take this chart and tilt it 45 degrees counterclockwise, and we get this chart here. Now, if you look closely, every number on this side, on the right side, has an opposite number on the left side. There's 13 and 31, 14 and 41, 24 and 42, 36 and 63. No matter where you go on this chart, everything is the opposite on the right side as on the left side. Perfect symmetry of number. I mean, it's like a butterfly. There's not one wrong thing in it. So right down the center, you'll see the multiples of 11, 11, 22, 33. These are called the palindromic numbers. Palindrome is like a word, like Bob. It's the same forward as it is backward. So this is just applied to numbers. And they're all the multiples of 11. They are the opposites of themselves right in the center of the chart. And then the horizontal midline of this chart is the 9 wave. Well, multiples of 9, 18, 27, 36, 45, and then they all reverse, 54, 63, 72, 81. They're all the opposites. So this is called the 9 wave, 18, 81, 27, 72. So here's that rhythm, 1, 2, 3, 4, starting with 18, 1, 2, 3, 4, 5, 6, 7, 8. Marshall calls it the +4, -4. And then that makes an octave. And then the 9th thing is the null thing. And essentially, you know, we use base 10 for our base. In any base, the transpalindromizing number, like what 9 does, is 1 less than the base number, and then the palindromizing number is always 1 more than the base number, 11. So down at the bottom of the chart, you'll see 11 times 9 equals 99. Well, that becomes the transpalindromizing number for the 3-digit range of numbers. In other words, these are the multiples of 99. 198, 297, 396, 185, and then they're all backwards again, 594, 396, all the opposites. So the next wave is the 99 times 11, which is the 1089 wave. And you see again 1089, 9801, and all of these opposites, this rhythm still happens, but then a nave is formed. A nave is the central part, and this one is 5445. What that does, it causes the next wave to be the 10890 wave, then the 1089000 wave, and then the 1089000 wave. So this idea of this this octave null 9 rhythm goes all the way through numbers, starting all the way from 1, 2, 3, 4, 5, 6, 7, 8, all the way down to as high as you ever want to go. And so this is what John Dee calls consumata. And then on the upper left-hand quadrant, he even writes the word consumata. And then he shows 1, 2, 3, 4, and then on the left, 5, 6, 7, 8. And the Greeks called 9 the horizon number because it's on the horizon before all the double-digit numbers. And so that's 9, the null 9 up at the top. And then up on the left, he says octonarius are crosses. He more riddling about it. And in his other chart, here you can see 1, 2, 3, 4, 5, 6, 7, 8. And then he even hides it in his listing of the alchemical stages, prep, putrefaction, separation, and then there's a pause at 4, and then 5's coagulation, trinity, and then there's a pause at 8, and then there's another one, 9, which begins with the letter I, and in Latin, the 9th letter is I. So these are all riddles about this this consumata. Whew, one more sequence, sorry, and don't try and remember all these. We'll review them in a second here. This one is very simple. It's 12 times the primes in their consecutive order. He calls it metamorphosis. In order to metamorphosis, you have to understand the single digits. These are the only digits we got, bro. Ain't no more. All numbers are made up for just these digits and 0. There's a placeholder thing. But we see them as numbers, you know, on telephones and telephone and addresses. We should look at and understand the quality of the numbers and how they grow. So essentially, we start with num1, this wholeness, and then that breaks into this whole 2 thing. Well, 4 and 8 are related to 2. So we say that 4, to make 4, you only need 2 more because you already got a 2. And then if you already got a 4, then you only need 2 to make 8. Well, the same thing with once you get to 3, 9 is related to 3, and so you only need 3 to get to 9. So let's just assemble all of this data that we have here so far. Up on the top here, we got 1, 2, 3, 4, only needs 2. And then we can throw in 6 because we got 2 and 3. That doesn't need anything to make it work. And then you got 8 needs 2, and then 9 needs 2. Well, the 2 digits we were missing is 5 and 7 here, and these are. But you'll see so far what we have is 1, 2, 3, 2, which multiplies to 12, and then 2, 3, and then if we add 5 and 7 at the end, then all of a sudden we have this recipe: 12 times the primes, and these numbers. And here's what they look like: 12 times 2 is 24. Times 3 is 70. 24 times 3 is 72. 72 times 5 is 360. And then 360 times 7 is this number 2520. And D calls this number is Sabbatizad. But let's just start at the top here. And when D writes one of his theorems, he says, on the equinox, there are 12 hours of daylight and 12 hours of darkness. That's why they call it equinox, equal night, which makes 24 hours in total. And he writes this in one of his theorems. Well, there's the first 2 numbers. And then 72 is famous because they're the 72 names of God in what's called the Shema Forash, the 72 angels and the super celestial angels. And the 360 is important because it's the number of degrees in a circle. And then D calls this number 2,520 the Sabbatizat. Well, what's so special about this number is the way that we've created it, it's the lowest number that's evenly divisible by all the single digits. All of 1, 2, 3, 4, 5, 7, 8, all divide evenly into 2520. No other number lower can you divide into, it will divide to all of these numbers. Now, you might say why that's important. Why that's important? Well, Plato knew it was important because he says in Laws the ideal number for a city is 5,040. Well, 5,040 is 2520 times 2. So he knew that if you organize the city with 5,040 or 2520, you could divide things any number of ways. The way I like to talk about it is like in a kindergarten. The ideal number for people in a kindergarten or a school is 24, because you can divide them into halves, you can divide them into quarters, you can divide them into thirds, you can divide them into six, you can divide them. There are many ways to, well, 2520 or 5040. There are just many ways to divide these. So, the tax system might use this, the division of land might use for this. And he says, for an ideal society, you want to use ideal numbers. And so this is what Dee was all about, trying to bring the numerical philosophy into politics. Now, Dee writes the word sabbatizat actually in his Thus the World is Created chart. As I mentioned before, the sabbati part means 7, and then the sabbatizat is his word for 2,520. And what that means is 7 circles. If each circle is 360 degrees, that makes 2,520, the sabbatizat. And so in his book, Dee says, my mind has been pregnant with this book continuously for the past 7 years. He tells this to the king in the introduction. Well, the Greeks rounded the year off to 360 days. So he's saying, I spent 2,520 days on this book. So Dee hides this stuff all over different ways. The main point here is that Dee's magisterial number, 252, and Dee's sabbatizat are opposites of each other. In other words, 2520, you flip it over, you get 0252. So, and remember, Marshall didn't see these as separate numbers. He saw them as integrated. The idea of reciprocity combines these two numbers. So the way to show the beautiful symmetry of these numbers, the metamorphosis numbers, is in what we call number wheels. And Marshall showed me how these worked, and I made them a little bit neater to show people. So this is the 12 wheel, and basically we starting at the upper right there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 rays. And then I've made in dark gray, all of the prime numbers are in dark gray, 13, 37, 61, all of that. And then to accentuate the rows, I've made some of them lighter gray, but basically all the prime numbers will only fall into these 4 rows. It's perfect symmetry. You can divide this, you can flip it vertically, flip it horizontally, or see this in a camera obscura upside down and backwards, and it's always going to look the same. So this is the 24 wheel. You can see that there's 24 in the center here. And then all the primes will only fall in these 8 rays. I know it looks like a Templar cross of the symmetry. And again, this is symmetrical vertically, horizontally, and in a camera obscura upside down and backwards. Just by contrast, I'll show you the 30 wheel. Now, this has symmetry, left side and right side, but not upside down. Not on a horizontal axis. The upper part is different than the bottom. That is not a metamorphosis number. It doesn't have this beautiful symmetry. The 72 wheel, this does have symmetry. This is the next metamorphosis number. All the primes fall in these beautiful rays. It's like a ray of sunshine. To show it graphically, here I just stress just the rays that they're into. I mean, it's perfect. And then the 360 wheel is the same way. And then I couldn't even draw the 2,520 wheel but it would look just like this beautiful symmetry. So the numbers don't stop at 2520. If you continue multiplying by the prime numbers, they go on. 27720, and then there's the 13 times 27720 is 360. Look at that number. That's 2 circles. That's unbelievable that number all of a sudden shows up. And then times 17 is 2160. And then when you get into 19 and 23, you're starting to get into the millions and such. So Dee says that, once you start to get that high, these aren't even numerable numbers. They didn't even count them. We can't, you're not going to count out packets of seeds that are that much. But they do go on forever, and they continue much further. So to summarize, in this chart here, you got 12, 24, 72, 360, and these are the numbers that divide into it. And you can see they accumulate as you go up. The 2520 has all 1 through 9, and then when we get up to 2000, 612, 6120 is divisible by all these numbers up to 18, except one number. Oy, oy, oy. He divides by 1, but not 16. All these other numbers. So in order for it to divide by 16, you're going to have to double it. You see, it's an odd number. It ends in 0.5. So to make it divide by 16, you got to double it. So we double this number to find out a number that's divisible by all the numbers up to 1 to 16. Drum roll. This number, 12,252,240. Look at this number. It's got 12 in it. It's got 24, the first two Metamorphosis numbers, and it's got 252. Or if you add the 0, it's 2520. This number is the lowest number divisible by all the single digits and up to 18. And so here it is up at the top here. You see we multiplied by 2 to get this special number. And I claim that D calls this and here they are. Here's all the multiples of the numbers to find all of those numbers to show you my math. And so I call this number 12,225,240 D's rare gift to Maximilian. He tells the Maximilian he has this very rare gift that he'd like to give to him, and he calls it another place the exemplar number of all things numerable. Well, it's a pretty rare gift, and nobody knew about it. Maximilian, all these guys, D figured it out. This is the lowest number that has all of this beautiful symmetry packed in it. In D's chart, there, as you see, that he actually includes the word metamorphosis. And then down at the bottom, he has 1, 2, 2, 3, which is his what's called artificial quaternary. These multiply to 12, and which is the beginning of the metamorphosis sequence. I call it the seed. And then he also has 12 and 24 over on the right here with these other numbers. And so in his other chart here, you see he has 12 and 24. And then down at the bottom, he has 252. Well, 252 we see is related to 25. So these number sequences, which I've explained, and I know it's a lot to absorb, they're all interconnected in various ways. And I don't want to get too complex about it, but here's an example. If you start off with the first 3 metamorphosis numbers, which are 12, 24, and 72, and add their reflective mates or their opposites, you get to 33 and 66, which makes 99. Well, 99 is the key number in consummata, which is the transpalindromizer for the 3-digit range. So we started with metamorphosis, ended up with consummata. That's just one example. Here's another one. In Nicomachus's Greatest and Most Perfect Harmony, we're comparing these numbers 6 to 12, 8 to 12, 9 to 12. These are the harmonies. And then D's artificial quaternary sums to 12. But basically, that's why the seed of the metamorphosis numbers is 12. Well, I don't want to conflict too much about that number stuff now. Well, here's one more in the +4 -4 octave null 9 rhythm. Our base number is 10, and that is it goes along with the symmetry of the decad. Well, D hides this riddle that he knows about 9, 10, and 11. At the very end of his chart, of the book, the Monas Hieroglyphica, he has this chart that says, "Intellecticus judicat veritatem." Let the intellect judge the truth. But you'll notice that the I, the T, and the L are unusually capitalized. Well, in Latin, the 9th letter is I, the 11th letter is L, and right in between are the letters TEN, 9, 10, 11. That's D's little clever way of hiding his knowledge about these numbers. So what's so special about 252? You know, I showed you 2520. That one is the lowest number divided by all the single digits. But why 252? D calls it in his book. He calls it duecenta quinquaginta duo, which means in Latin 252. He explains it a couple of places. And as I said, it's the sacred number of the Hindus plus his magisterial number. And here's looking at it in pi shape. Basically, it's 3 tenths and 7 tenths make a whole. And so but here's a way, and I just put this one in to tie this in with Dan Winter's stuff, because Dan asked me last time, well, does he mention the golden ratio at all? And I'm like, he doesn't really. He doesn't talk much about it, but it was very, very well known. You know, Luca Pacioli, they all write about it, and I'm sure Dee knew about it. But I changed my mind, and D is kind of integrating this. And so here you'll see an equilateral triangle has interior angles of 60 degrees each. The square is 90 degrees each, but a pentagon, it's 108 degrees each, which means the opposing angle is 252. So there is 252 quite naturally in a very elementary polygon. But here's where it gets cool. Inside this pentagon, you could make a five-pointed star, and this is the one that shows all of the golden mean ratios. Well, the exterior angle of every one of those is 108, so the interior angle is 252. So this is intimately connected, but I'm going to have to let you figure out how it goes even more connected. But that's pretty cool that it connects with the golden ratio. Now, the other thing about 252 is in this chart of double and single digit numbers, the opposite of 5 is 5, the opposite of 9 is 9, the opposite of 11 is 11. The first pair we have is 12 and 21, right? The first one that can possibly have an opposite. Well, guess what 12 times 21 equals? 252, D's number. Whoa, is that cool or what? And so here's another thing called Pascal's triangle. Well, now, it's a very simple thing. You just put number 1 along the left edge and along the right edge, and then you add up the numbers, like up at the top 1 and 1, and below it you put in 2. 1 and 2 makes 3, and 1 and 2. You just continue adding every number of the two numbers up above, and it makes the number below it. So you make this gradual thing. Now, this has been known way before Blaise Pascal, and Dee knew about it as well. Well, look, right in the center of this chart is 252. Now, admittedly, this chart goes on forever. You can keep continuing, so it's not always in the center of the chart. But if you take the numbers and I've darkened the ones on the side because they're all the same, and then I've darkened with light gray all of the odd numbers in medium gray, and then all of the even numbers are in white. Well, focus on just the white numbers for a second. There's this triangle of white numbers in the center. And right in the center of it is 252. And then surrounding this are 3 more beautiful triangles, small triangles. The whole thing has this perfect symmetry around 252. I call 252 a nexus number. Oh, and by the way, the Pascal's triangle is a giant equilateral triangle. That's D's name. So the whole idea of 252 is related to 22520. And these are most important. In order to show this, basically 252, let's break that down. As I said before, it's 12 times 21, 252. Well, 2520 is 120 times 21. And remember the first slide I showed you? In Dee's book from 1558, he shows that very equation right in the middle of the book. Whoa, Jim, that's cool. Anyway, so in his chart, in his book, Dee shows 12 and 24 a couple of places in calculating these theorems. And in his Thus the World is Created chart, he has the numbers 12 and 24. Well, you'll notice on the right-hand side, the terrestrial segment, which is a part of a circle, is half of what the etheric celestial is. And so if that's 12 and that's 24, then you calculate the amount of area in these, then the above part would be 72 in the supercelestial part. Well, that's the number of angels. So 12, 24, and 72 are these proportions of these shapes here, and they sum up to 108. You look down at the bottom. 108 is the sum of these first 3 metamorphosis numbers, which is the sacred number of the Hindus. And so what Dee is wanting us to do here is to extend, or we have to balloon the shape a little bit so that the 12, 24, 72 is 108, and then you add 252 more to make a whole 360. Well, it's not a full 360, it's making a half circle here, but it is making a perfect spherical half circle. And what that means, the reason that Dee hid this in there was to show us that in this, what I call the ballooned, Thus the World was Created chart, it makes the whole chart of the proportion of 2 circles, 2 opposing circles, the proportions of 1 to 2. And if you take just the rectangular part of the chart, then that is 2 to 3. Dee made exactly these proportions. And then the front title of the title page of the book is the 3 to 4 proportion. So he hid in his main drawings in these books, he hid the idea of a 3 to 4, 2 to 3, and 1 to 2. All the harmonious proportions are in the idea of the book himself, which is pretty amazing. So 252 also appears in geometry, and this is where, when I Googled it, I found out that this guy, Buckminster Fuller, was talking all about geometry. And Bucky lived from 1895 to 1983, and he wrote these 2 books called Synergetics. Well, he also invented the geodesic dome. If you go down to Walt Disney World in Florida, or all of these domes, he invented the idea of compiling all of these things into spheres. And his main thing that he kept on saying, he boiled it down. He's a very verbose guy, and you could read his words, but he boiled this one sentence down to 2 things. Unity equals 2. Now, when we think of unity, we think of like one, wholeness, unit, the whole thing. And by the way, the first person to use the word English unit in an English book was John Dee. He coined the word from the Latin word. But Bucky says that unity is two-ness. It's always got to be 2 things to combine to make a unity. One thing is not a unity by itself. It takes a lot of thinking about this. It's so simple, but it's really quite heavy. And he says, even in a sphere, you've got outsidedness and insidedness. You've got, in any kind of shape, you've got the convex shape, and like here's this ball I'm holding. Well, what if you're a little ant inside of the ball? You're looking up at the convex. That's your reality. So it's convex, and so everything has duality to as this idea of union of opposites. And he wrote this in these 2 books called Synergetics 1 and Synergetics 2. They're a little challenging to read, but fortunately, there's a book by Amy Edmondson. She studied with him at MIT. It's called A Fuller Explanation, and it's actually free online. But you can get a copy of it. And if you want to read simple Bucky, this is it here. It's got all of the basic stuff here. It got me started. Then I was able to read Bucky's stuff a little more. What Bucky's is basically saying is, you're going to start with 1 circle, and 6 around 1. This is called the closest packing of circles, which, again, if each one is 360, that makes 2520. But 6 around 1 is the closest way, no matter what size circles they are, they could be sewer caps or whatever. If they're all the same size, 6 is going to fit exactly around 1, not 5, not 4, not 4, exactly 6. Well, in spheres, in 3Ds, you get 13 spheres fit around 1 in what's called the closest packing of spheres. Now, that's just 1 layer. You'll see that there's here, I'll break it apart. There's 1 central sphere, and then there's 6 around it, and then there's 3 that nest on the top and 3 that nest on the bottom. So there's a total of 12 around 1. So there's a total of 13 of them. And these spheres make this shape called a cuboctahedral shape. In other words, it's this shape right here. It has square faces and triangular faces, which I'll explain a little more in a second. Here you'll see the cuboctahedron, and here the cuboctahedron in it, which has 12 vertices and 24 edges into it. So basically, there's 5 Platonic solids. You got the tetrahedron, the octahedron, the icosahedron, the cube, and the dodecahedron. And then Archimedes says, well, these are all polyhedra that are regular. They have only 1 kind of face, each one. Well, then Archimedes says, well, there are more that have several kinds of faces, and these are called Archimedean solids, the icosahedron only. But the simplest one of these Archimedeans is the cuboctahedron. And basically, if you were to take the octahedron and the cube and to combine them, and then cut off all the pointy stellations, the star points, you would get the cuboctahedron. There it is right there, just oriented. But Bucky says, I don't like to call it a cuboctahedron or a Platonic solid. These aren't solids. He saw them as energy events. Here you see that's the simplest cuboctahedron. And the reason that Bucky was so excited about it was, if you were to make all of these different shapes, tetrahedron, octahedron, and then make the radiating rays from them, the radians are all different sizes. And here I've measured them on the first. The only the only Platonic or Archimedean solid in which the median radian, the radian that sticks out from the center, is the same length as the edge vector, is the cube octahedron, 1-to-1 between the so this is just beautiful, perfect harmony in its own shape. The radiating vectors and the edge vectors are of equal length. I made this all out of 4-inch lollipop sticks. If you tried to make that with any other shape and make the radians, you'd have to get different, cut the lollipop chips or you're starting them. So Bucky was so excited about this shape, he called it the vector equilibrium. He says, this is an energy event, and think of this as pulsating in and pulsating out. And when it pulsates in and collapses in the center, it comes out the other side. So the center is pointed like a null point, right in the middle, which is what Dan talks about in his work. It's the center point. And Bucky says, and this is his quote, "Zero pulsation in the vector equilibrium is the nearest approach we will ever know to eternity or God." That's pretty heavy. So he's talking about the zero pulsation, the center point here, and so if we take one central sphere, 12 spheres will fit around it. And then if we were to continue on, there would be 42 in the next layer, and then 92 in the next layer after that. And here I've just glued ping pong balls. And then there's 162 in the next layer. And it always makes this cube octahedral shape that has triangles and squares. Well, Leonard Euler, he figured out, he says, look, you take the layer number, you square it, and you put a 2 at the end. So layer 2, 2 times 2 is 4. Layer 2. And so he says this is a very simple way to figure out the formula. Like layer 4, you square it, do 16, you put a 2 at the end. How many be in the fifth layer? 5 times 5 is 25, put a 2 at the end. 252. All of a sudden, John Dee's number shows up in geometry. There's no numbers here. This is ping pong balls. 252 of them are in the fifth layer. Now, you might say, well, you could go on to 362 and then 492 and 12. What's so special about 252 in this layer 5? You can see you could go on and on. Well, here's what's special, and Bucky explains this in his book, and so does Amy. She says, in layer 1, you have 12 spheres, but there's one in the center. So if you look, you can see the one in the center. There's a little space there. You can see it. It's not totally hidden. It's not a true nucleus. But when you get to 42, which is the next layer, all of that stuff in the middle is hidden. So you have a true nucleus. Well, 42 plus 12 plus 1 makes what they call a 55-sphere cluster. This is what it looks like. And only then do you have a true nucleus. Well, when you get to 252, there are 8 new 55-sphere clusters that have been born just inside each one of these triangular faces. 8 new nuclei have been created. It's the time of great birth. There is the one in the center, the white one, and then there is where the 8 new nuclei have been born. So Bucky says that this stage, the fifth layer, is like the most important. So to summarize here, 252, we saw that it's a product of 12 times 21 in the diamond-shaped chart. It's also in the middle of Pascal's triangle. You add 108, you get 360. It's the special number, and then in geometry, it's in the center of the fifth layer. It is the fifth layer. So I call it a nexus number. It's always in the middle of someplace. And once I started studying more, I'm like, these are all sort of this is geometry and math together. Well, now Bucky would give lectures. He lectured all around the world, and he would always start by saying a 6-sided figure does not hold its shape. A 5-sided figure does not hold its shape. A 4-sided figure does not hold its shape. And why are we building houses like this? He says the triangle. This is the one that only holds its shape. Well, in 3 dimensions, that becomes a tetrahedron. He says perfectly solid. Why don't we build stuff with this stuff here? Here he is holding this tetrahedron, and so he calls this the building block of nature. And he says, now just to be clarified, this is not a pyramid of Giza. That has 4 sides. It has a square base. This is, it has a triangular base. It's triangles on all sides. Now, Bucky says if you take 2 of these tip-to-tip tetrahedra, and this is the 2 tip-to-tip tetrahedra, 1 and here, he calls this the tuned-in, tuned-out structural experience of universe. That's pretty heavy. Now, you have to make sure when you attach these 2 together that the left edge becomes the right edge, right becomes the left edge, where these all go through each other. And if you look at it from end on, I don't know if you can see it in here, but it makes a Star of David. There's two triangle, upside down triangle, the whole thing. So this shape here, I call it a Bucky bow tie, because Bucky like wearing bow ties, and that's sort of what it is. It's an expression of the union of opposites. Now, this is nothing new. Nicholas of Cusa, he calls this coincidentia oppositorum, the union of opposites. And Dee writes in his 1558 Propetumata Aphoristica, aphorism number 9, which 9 is a special number, as you can see, that whatever is in the universe has agreement, accord, and similar form with something else. Dee is talking about this in again, Bucky, unity equals 2, the idea of oppositeness. So the idea of opposites, and as we showed you, is two tangent circles. It can be two tangent spheres, or the two tip-to-tip tetrahedra. They all expressing the idea of oppositeness. And if you take 4 of these cuboid tetrahedra Bucky bow ties, combine them, you make this shape, a cuboctahedron. 4 Bucky, and Bucky calls this, as I said, the vector equilibrium. He says the center point is like the null 9. He says it's like in consummata, that null 9, but also he says in the energy event, he says it's like Grand Central Station. All the trains go through Grand Central Station, and that's the nexus point, but they don't stay there. They're not hanging out there. They don't go. They go to Boston, they go to Chicago, and he says that is the place where it all implodes. The idea of this central point. So that is exactly the 9th. Also in consummata, it's the 9th thing in the middle. So which is basically the same thing in consummata, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here we got geometry and numbers telling the same story. And that's why Marshall says geometry and arithmetic are 2 sides of the same coin. You know, we learned math in school in the 8th grade. You take a class in geometry, it's all about shapes. Well, Marshall saw that they're the exact same thing. And John Dee saw the same thing in his preface to the Euclid's Elements, Dee in 1570. He helped translate Euclid's Elements, 500 pages, and Dee added corollaries and addendums. Brilliant math. I can't even read it. It's so sophisticated. And at the very beginning, Dee writes a preface in which he defines all the known mathematical arts at the time: perspective, music, astronomy, cosmography, all of these things. And he says these are all related to 2 things: the principal arts, arithmetic and geometry. Dee was total math geek. Everything was mathematics with John Dee. So what John Dee discovered in the 1500s was the same thing that Buckminster Fuller about geometry and Robert Marshall discovered at numbers in the 1900s. And here is the front title page for the first English translation of Euclid's Elements, and you'll see Billingsley gets mostly credit, but Dee did most of the translation. He's down on the bottom here. And at the very end of this book, which is, as I said, 500 pages long, they added this treatise by Fluffus, and he was the Comte de Candide. He was a French geometer, and he had figured out stuff, and so they addended to the back of the book. Well, in that, he shows the cuboctahedron. They called it an exoctahedron. Exo means 6, octahedron means 8. And so this is their name for it. And even at a folded cutout, if you cut it out and fold it out, you could make your own cuboctahedron. And then he also shows how it's constructed geometrically. So Dee, in his book, he cryptically talks about the 8 triangular faces. In the upper part of his chart, if you made X's, there are 8 triangles. In the lower part of his chart, there are 6 quaternaries, or listings of 4 things. So that's how he hides this idea of it. And also in his chart, he has the numbers 12, 13, 24, 25. Well, these are cuboctahedral numbers. 12 around 1 makes 13. There's 24 edges in a cuboctahedron, and there are 25 great circles if you blow up a spherical cuboctahedron, all the crossing points. So these are all about it. And Dee, in his book, he even makes riddles about it. He says, for people, you've seen the surfaces of elements which are in close proximity are coordinated, connected, and joined together by a law decreed by God Almighty and a bond unable to be loosened of nature. He's talking about the idea of these closest packing of circles. Even it tells this parable about this scarab beetle who's rolling his dung balls, and the eagle is bothering him, and they both deposit their dung balls and the round eagle's eggs in Jupiter's laps. Well, they're all gonna combine with the closest packing of spheres. Oranges do this at the grocery store. This is just how things pack. And it also, the frame, leads to a thing called space frame, which Bucky sort of invented. But this whole idea, and this is one of the last concluding chapters here, of geometry and number, also involves light. And that's where I come in. I was a professional photographer for 40 years in Providence, Rhode Island. Took pictures of people, products, and places for advertising agencies and such. And a photographer is someone who draws with light. Photos, light. Graphes, light drawing. And so I worked for many years with what's called a view camera, or a 4x5 camera. I even had one that was 8x10, the image on the back. Well, everything is upside down and backwards in a camera, because a camera is just a camera obscura. And so I had to, with the dark cloth over my head, see stuff upside down and say, oh, move this to the left. Oh, I mean, right. I mean, I have to, in my mind, actually learned how to see things properly upside down and backwards. So the idea in a camera obscura, which is the basis of a camera, is everything becomes inverted. So here's a room that I've put with the words lux, LVX, which is light, and a hole in the center, and then there's a dark room on the right hand side. And so you'll see that the idea of this tip-to-tip tetrahedra here is what is the idea of the camera obscura. So here's what I says, Jim Egan. This is what I'll be famous for when I croak. The most economical geometrical depiction of the behavior of light in a camera obscura is two tip-to-tip tetrahedra. Pretty simple, I think, but I never heard anybody say it. Bucky didn't say it. Marshall didn't say it. They didn't tie it in with light, with how we see. And so an eye is actually a camera obscura. Everything is upside down on our retina. Our brain flips it around. So we don't even know we're seeing everything upside down and backwards, but we are. Everybody is. And D even makes a riddle about it. You see, his Mona symbol is not just all these beautiful proportions and the sun and the moon. It's also a little cyclops stick figure. And when he describes his geometric depiction of the Monas, look what number he uses for the center of the eye, the sun circle. The letter I, which is like an eye. The whole thing is a riddle. These Elizabethans, they love to riddle, but modern men, they don't do riddles. They think that it's childish. I get riddles. That's why I understand D. So D is, I'm making this whole idea of I and making this cyclops. By the way, the word cyclops itself, D knew, he taught Latin, comes from the word cyclos, which means circle, and ops, which means eye, cyclops. So the whole thing is one big riddle. And in his book, D says, of all the sciences to learn, perspective, music, astronomy, perspective is the first one you need to learn. Of everything. We don't teach that in school today. And he says, because without understanding perspective, you won't be able to understand astronomical appearances for three reasons. First, it deals with light, and light is the first of God's creatures. Look at the Bible. First thing in the Bible, right? Let there be light. Came before day, before man, beast, anything. Light was first. And so on that day, when there was first light, if there was a cave someplace and there was a hole in the cave, you're going to get a camera obscura. So you can't make a dark room with a hole in it and not get the camera obscura effect. It happens. D also says it deals with the eye, the light of our body, and his sense most mighty, and his organ most artificial, which means artful and geometrical. D loved the eye and the idea of how we see. And in his advice in the Monas Hieroglyphica, he says, if you take a tetrahedron, which when made full circle, if both sides of it, full circle, a mirror may be found. That's the image in the camera obscura. It's like an image, like a mirror image. You see all the details, everything, all the colors, everything. Even when the sun's being blocked by clouds, camera obscura still work on cloudy days. It doesn't matter. He's just not as bright. Can reduce any kinds of stone and metal into impalpable powders. Well, in the camera obscura, you try and touch the image. It feels like a powder. You can't touch it. By the force of truly the very strongest heat. Well, the heat is that's sun. That's the force. That's where we get our light from, as well as our heat. So this whole thing is a riddle. Here is a camera obscura my friend set up at the Rhode Island School of Design. Here you'll see, and the image on the out. It's color. It's upside down and backwards, but it's like powder. You can't touch it. There's nothing there. And so Dee's second riddle is, he says, I can show you by actual experience that the element of earth can float above that of water. Well, if his kids are playing in the mud outside his home on the Thames River, inside, the element of earth floats above that of water. And as I showed this before, intellectica judicat veritatem, down at the bottom, he says, the eye of the vulgar here will be obscured and most distrustful. Well, oculus means eye, caligipat means obscura. He's riddling about the camera obscura right there. And in his book, he says, in Theorem 5, he says, if you join the sun and the moon together on this first day, the light of the philosophers was made. He knew, let there be light. That's when the first camera obscura, the light was made. The idea of conjunctio, the union of opposites. They could be the sun and the moon, which Dee says in one of his theorems. To our eye, they appear to be the same size from here. And they have, in his monad symbol, they're the same diameter. And the light of the two tip-to-tip tetrahedra, they're the exact opposites. And so the idea of the camera obscura, you know, the Greeks knew about it, and they didn't really understand it fully. But a monk in 875 named Helperic, he put a hole in a wall, and he says, if you mark off where you see the sun on the horizon every day, you'll have a calendar. And so this is 1544. This is the first image we have of a camera obscura by Geoffrisius. And Geoffrisius was John Dee's teacher. And here you see an eclipse of the moon inside a dark room. Well, John Dee knew all about the camera obscura and how beautiful and how it had to do with light, and how it all had to do with geometry as well as numbers. Well, all of these guys, Agrippa, Barbaro, Cardano, Della Porta, all these Renaissance guys, Da Vinci, they all talk about the camera obscura. You can read it in their books. Because at the time, in 1583, the late 1500s, they converted these giant cathedrals that had already been built into camera obscura rooms. They put an aperture way up at the top. You see way up at the, oh, there's a hole in the ceiling, and a meridiana line down at the bottom, which is a noon line. And by watching where the sun crossed on the summer solstice, on the equinoxes, and on the winter solstice, and counting the number of days, they were able to prove to Pope Gregory XIII that the Julian calendar was out of sync from the sun, leading to the Gregorian calendar, 1584. So the camera obscura was very important. You can tell the time of day and the day of the year from one of these internal sundials. And Dee was in charge of recommending whether they change the calendar in England. He knew all about this. He quotes Hipparchus, he quotes all of these guys. And then after Dee's time, the artists started to use the idea of the camera obscura in art, to learn the art of perspective, of Vermeer and Canaletto. And then in the 1800s, they put film in the back and made the first photographs. And then you got box cameras in the 1900s, and then Nikons and Leicas. And now we take pictures on our cell phone. But even in a cell phone, the image is upside down. That's how it works. So the idea of the camera obscura that started about in the 1500s that John Dee was big on, that became a still photo camera, later became motion picture camera, later became television, later became computer, later became digital camera and smartphone. And that's what we're here today. We're seeing a Zoom meeting because of all of this camera obscura stuff. So to summarize, what Buckminster Fuller found about geometry, what Marshall found out about number, and what I found out about light is what John Dee's book is about in the 1500s, geometry, number, and light. And he was that far advanced ahead of all of us. And why was he able to understand all these things? These things don't change. Geometry, number, light, they're all kind of the same. We just have sort of forgetfulness sometimes about it. And remember, John Dee was one of the greatest minds of all time. And that chart in which he summarizes all of his number and geometry, he calls it, "Thus the world is created." He thought that this was really the creation, and he wanted to save this for humanity. But if he came out and just explained it all, it might get burned by the Catholic Church, by the church, whoever. And so he wrote it cryptically in this book, and I was able to figure it out. But the reason I was, and I have to thank Ambix, even though they rejected me and wouldn't let me use their copy of it, when he told me his expression with the senior editor, he said, "Translate it in your own light." didn't know what he meant, though. Well, now I understood. It all has to do with light and how I was able to bring this idea of the camera obscura to it. So I want to thank you, all your eyeballs out there, for watching all of this stuff. If you want to know more about Jim Egan, my books, James Allen Egan, on Amazon, or Newport Tower Museum, Newport Tower Facebook, and I thank you very much for your attention. I hope you had as much fun as I did.
And you're changing hats.
Yeah, I'm trying to be modern here, trying a little bit of everything here. Yeah.
It's wonderful. It's wonderful. And just to try to get a little sense of, Vincent Bridges used to accuse me of having memories of John Dee. And I would sometimes think, oh, well, some of that's numerology. But then we realized that the difference between numerology and physics is when you predict what a wave is going to do. And of course, so pattern recognition turns into wave mechanics at that point. And where this all becomes such powerful wave mechanics, I think there's some keywords in your text where you talk about consummata and nexus point. Specifically, what still fascinates me about John Dee and his study of light was when he used the scintillation point to communicate with ancestors and use what is apparently a quasi-phase conjugate mirror in his showstone for angel phone calls. So the point is that the mathematics is telling us where waves can implode and compress. And at the nexus point, or what you call consummata, I relate to the idea of literally consumed perspective. And consumed perspective is where all viewpoints become one, like, a million eyeballs on the peacock's feather, or the million eyeballs on the facets of the insect eye. They all, e pluribus unum, they all become one. So I call that the point of perfect charge collapse, or the phase conjugate point. The point being, this is the physics of ancestor phone calls and angel communication and scrying, because at the point of implosive phase conjugation of the wave mechanics of the opposite, where the pinhole camera turns inside out, literally the conjugate point, predicted by the mathematics, but only confirmed by the implosive wave mechanics, is the point where they call it ancestor phone calls, or longitudinal interferometry. It's simply the points of successful compression on the dodecacosa Earth grid where telepathy is in fact enabled. So I think John Dee was working up to the wave mechanics of the phase conjugate point being the ultimate communication device for all of nature. Literally all action at a distance is those longitudinal nodes. But John Dee didn't have the language of wave mechanics to talk about phase conjugation, implosion, or longitudinal interferometry. But I say that's where his work was pointing. And when the waves of light converge, like you say, two tetrahedron, or I call it two pine cones kissing noses, where the waves of light converge at the conjugate point, you have the possibility of telepathy and ancestor communication, ancestor phone calls, literally the grid wave mechanics of the collective unconscious, phase conjugate, longitudinal interferometry being the physics of clairvoyance, for example. This was all right, absolutely what John Dee wanted to know. How was he going to communicate with angelic forces? He was studying phase conjugate longitudinal interferometry, but didn't have the language to talk about it. And what the mathematics is only an approach to the physics of where waves can collapse, implode, and conjugate. So I say our language today, it stands on the shoulders of John Dee, but he didn't know how to turn the language into real optical wave mechanics, phase conjugation. So that's my little, for what it's worth.
No, I agree. It's kind of like if you have a camera obscura and you got a hole in a room, but if the lights are on in the room, you won't see the image. But if you darken the room and make it totally dark, in other words, really put black plastic up on the wall, make it then all of a sudden the image comes out. It's always there. You can't get a camera obscura not to happen. but you won't see the image. You won't understand it unless there's a certain darkness, and that's the opposite of the brightness outside.
Well, and then that might imply that if your Newport Tower is in fact at a longitudinal node on the Earth grid, that if you go inside at sunrise, sunset, solstice, when the longitudinal four-wave mixing is working, and then close your eyes, you should see pictures.
Okay, I'll do it. I got 6 witches are coming up from Norwich, Connecticut to do the summer solstice. We had 96 people here for the winter solstice this last season. And there is a special event that happens. The light shines through the windows and such.
Ancestor memory at that date, I predict.
but I'll also tell you, when Verrazano came through sailing for the French king in 1525, he says that this bay right here is at the same latitude as Rome. And
there you go.
It's exactly the same. And it's also the same latitude as Constantinople, as Istanbul. They're all on this exact same line.
Ah, yes, which are literally the Stargate telepathy nodes. Beautiful, beautiful. Well, this has been such fun. It's wonderful. Tufan, I'm sure we want to at least talk about a few questions. Yes.
Yes, we have a few questions. First one from Maura. She asks, are you familiar with Alan Green's work on Shakespeare and the correlation of the Mona's Hieroglyphica as a sophisticated 654-bit cipher message that correlates to the sonnets of Shakespeare? He believes that John Dee, the real Shakespeare, was a man named Edward de Vere, 17th Earl of Oxford, wrote the plays and poems of William Shakespeare, and was a Mason, a Knight of the Round Table. Shakespeare's sonnets were actually published to hide the psychographic message telling where the original documents are hidden in the Holy Trinity Church in Oxford, inside a cavity in the altar in plain sight to protect the information, to be or not to be.org.
Yes, you know,
I'm familiar with Alan Green and his work. I have a couple of his books and the whole thing, but I actually I'm on a different train there. I don't think it was Edward de Vere. I think it was a fellow by the name of Sir Henry Neville, but I let who was actually Shakespeare. But I let everybody have their own a dream on this thing and their own take on it. But I will say this though. John Dee, lived from 1527 to 1603, the same time that Shakespeare lived, and they lived in the same town. And it wasn't that huge a town. And these are the two smartest guys that we've known for a long time. I'm like, to think that they didn't know each other, it's like, hello. So yes, Alan Green and these people there's big clue. And people, if they studied more about John Dee, and particularly these numbers, they would see connections between Shakespeare. I've written a whole book on Shakespeare and the Tempest in John Dee, and I'm working on more of it right now. So he's absolutely on the right wavelength. We're just on different wavelengths of it.
Alan Green did a great presentation on FractalU. He is amazing, but it is interesting that because he's saying basically that John Dee was behind the verses of Shakespeare directly. So interesting.
Well, I'm reading John Dee's language. When you read the Monas Hieroglyphic and you have a feeling for people's style, it is not Shakespearean language at all. It's very different. It's like having your math teacher try and talk to your English teacher, and it's just so. When people say the same thing about Sir Francis Bacon, they're like, "Oh, maybe Bacon was Shakespeare." I'm like, "Did you ever read any Bacon's work? It's got nothing to do with the lyrical quality of the sonnets." Which are, so anyways,
there you go. Which is De Vere.
Good question, though.
Yeah, good. Go ahead, Tufan. More questions? Yes, please.
If you guys want, in the meantime, we can maybe stop share to see our pictures bigger.
Do you know how to turn off screen share there, Jim?
Oh, sure.
Anzi asks, since the conversation is only about integers at that point, what would Dee say about irrational numbers?
Yeah, so he's asking a question about what Dee say about
irrational numbers.
Oh, there you go. Good, you got it off. Good. Okay. So irrational numbers like pi and phi.
Yeah, John Dee doesn't talk much about them. That's a very good question. He does talk about whole numbers, and that's what Marshall talks about, and even Fuller. They're like you have to deal with wholeness, 1, 2, 3, 4, 5, 6, 7, 8, 10, and so I don't really know, because you do have to take consideration pi and phi and all of these very important numbers that are irrational numbers, but D hadn't gotten to them yet.
That's where I say actual wave mechanics. Now, we have proven that in wave mechanics, phi golden ratio predicts maximum constructive wave interference, which is the real solution to nexus point. And so actually the transcendental or the irrational numbers predict implosion. Go ahead, Tufan.
I also wanted to say to Jim that I read some of his books, one being the seventh book on his website at newporttowermuseum.com, These Decade of Shapes and Plato's Number. And I really liked it a lot how Jim explains the intricate relationship and the progression of dual Platonic solids from one to another. Especially, it's very nice to see how dodecahedron and icosahedron as dual geometries, as dual Platonic solids, how they create each other through their stellated formations, which also something that we touch upon during our classes about the shape of the universe and the charge. And it's like the breathing in and out of the charge field in the universe as a fractal reflection of the ether. And another note about the importance of geometry and arithmetic that Jim was talking about, we can also tie this into the golden ratio, as the golden ratio is the only ratio in the universe of mathematics that holds both geometric and arithmetic progressions at the same time. So this is also something that points to golden ratio in early mathematicians' works, something that I wanted to add. And
Jim has been at this a long time. And in both cases, the dual of ecosadodeca and arithmetic and geometric progression golden ratio, that means the solution to implosion.
Yes.
Yeah, like their duals, the icosahedron, dodecahedron duals. Well, also another set of duals is the cube and the octahedron. They're duals; they fit inside each other well. Well, the cube and the octahedron makes the cube octahedron, which is the shape that these guys are all singing about.
It's interesting, however, the cube octa has powers of 2 octave ratios, which creates maximum destructive interference, literally the opposite of the possibility of implosion, hex, whereas the dodecacosa, because they make golden ratio, they imply directly implosion. So go ahead, Tufan, more questions, sure.
Yes, last one again from Maura. She says about what Jim was explaining earlier. It also means that non-visible light can be perceived. Could the same be true of magnetism and non-visible light?
Wow, that's a really good question. You know, the principle of how light works in a camera obscura is the same thing that any radiating thing like heat will work the same way. Sound will work the same way. If you're in a camera obscura, you're going to get the sound waves if you're in direct line with the thing. So the idea of magnetism, force of magnetism, probably works the same way with it. I'd have to put that over to Dan. What do you think?
Well, yeah, I would comment that, you know, that which makes the longitudinal component of the electromagnetic field able to go through anything, implying invisibility, but it will show up at the convergence point, the implosion point, the fractal nodes in the array, where it re-enters compression and then exchanges inertia with a transverse component. And that's where the invisible becomes the visible. And specifically, that is the answer to every question about how action at a distance occurs, because the longitudinal nodes will miraculously show up again, having passed through just about anything at the next compression node in the array, where telepathy is again available. So the invisible turning into visible is literally the difference between the transverse and the longitudinal component at the implosion point in the array. So that's the real electromagnetic solution to invisibility, and in fact, the solution to the physics of all action at a distance, in my view. Go ahead.
Interesting. In the Newport Tower, which is the building that I do my thing, there's one stone which is called Cumberlandite. It's a state stone of Rhode Island. It's only found one place in the world, Cumberland, Rhode Island. And there's a piece about this big in it, and it's on the exact north-south line of the tower. Well, it has a high iron content, so a magnet will stick to it, or it throws off a compass. So the people, when they came and built this, they knew that the Earth was a giant a magnet, but they didn't discover that until around 1500. So that proves that to me that it wasn't built earlier than that. But the idea of magnetism, this is a fellow guy by the name of Gilbert in England who studied it in the 1500s. This was all new knowledge for John Dee and his team too. So they were weaving this in as well. And Dee, as I said, he was a great navigator, and he taught people how to travel across the ocean where the longitudinal lines get close together. He invented a whole book and a whole diagram and a whole meter to figure this out. So yeah, these guys were into this whole magnetism thing.
And the art of navigation, you're right, Dee's specialty, the art of navigation, eventually becomes the aboriginal art of navigating the song lines, which is the longitudinal array, the ultimate heads-up compass, literally lucid dream navigation.
Well, there you go.
Go ahead, Tufan. Next question.
These were all the questions we have.
Oh, okay. Well, I would call that happily ever after. I think, Jim, you are to be congratulated. Your enthusiasm, your attention to detail, your beautiful slides. Really, Jim, thank you.
Well, thank you
For inspiring
us.
Jim. I get another beautiful view of John.
You should hear me sing and tap dance. Yeah, you just see nothing, man. Nothing.
Tufan reminds us that Jim Egan's books are available on his website as well. So please check Jim Egan, and we thank you. So
I shared the link in the chat box for the listener.
Great. So thank you, Jim. Thank you, everybody.
Thanks, Jim.
Hey, I wanted to show you one last thing, how to implode upon yourself. There you are, people.
It's an infinite mirror. On that note.
Talk to you later, everybody.
Bye, everyone. Thank
Bye.
you, Jim.
Thank you,
Tufan.
Thank you, Dan. Thank you.
Thanks, everyone.
Thank
Bye.
you, Tufan.
See you next week.
See you next week. Bye-bye.